Hello, Tom from Every Step Calculus, everystepphysics.com. A calculus problem with regard to related rates and a ladder against a wall. And we're going to find the change in the angle between the wall and the ladder in this video. I'll read it here. A 20-foot ladder is leaning against a wall. If the bottom of the ladder is sliding away from the wall at a constant rate of 3 inches per second, at what rate is the angle between the ladder and the wall changing when the bottom of the ladder is 10 feet away from the wall? Excuse me. Let's do it. Index 8 to get to my menu. I'm going to, in this problem it says related rates, so you go to choose that in the menu. But it's so far down, and I know that because I programmed this, that the average rate of change is the same thing, so I'm just going to use that. Save time. And I'm going to scroll down here to number 9, ladder and wall. And we're going to choose number 3, d theta dt, the angle. In this video, we're finding the change in the angle between the wall and the ladder, so number 2. And the ladder is moving away from the wall. So the ladder is moving on the ground. I choose that, which is the x-axis. Remember the x-axis and the y-axis, and you got the ladder here, the hypotenuse. And so the ladder is moving away from the wall at the rate of, you have to press alpha here before you enter anything in these entry lines here, at the rate of alpha 3 inches, number 5, per second. And it's moving away from the wall. If it was moving towards the wall, it would be a minus sign in front of the 3 here. Now notice this is inches per second, so be careful, because you have to change everything to have the same increments as this change when they give you this dx dt change. So, excuse me. So it's got 3 inches. I give you a chance to change it in case you made a mistake there, but I say it's okay. And now the ladder length is alpha. We give it as 20 feet. Well, 20 feet is not inches. So we're going to multiply that times 12. Gives us the hypotenuse for the ladder length is 240 inches. I say that's okay. And they give us the distance from the wall on the ground here, which is the x-axis. We choose the wall, and I'm going to enter the variable for that, which is 10 feet. Alpha 10. Now 10 feet is not inches, so we have to multiply times 12 to get the same increments. There's 120 inches. I say that's okay now. Now first we find the angle of the ladder and the wall. We use that by the arc sign here of x divided by z, which is the base times the z, times the, the hypotenuse. Z is the hypotenuse, and it turns out to be 30 degrees. And so then we have sine of theta is equal to x over z is equal to x over the amount that we computed, which is 240 inches. We're going to differentiate that, and the derivative, the derivative of sine of theta is cosine of theta, d theta dt, with respect to time, and then we use 1 over 240 dx dt. So that's the derivative of this right up here, okay, with respect to time. And we add the variables that we've determined or entered. Here's 3 there for the dx dt. And we do the computations. Turns out to be 0.01443 degrees per second. And when we multiply that times 0.0175, we get 0.00025 rads per second, depending upon what your professor determines for the test. So anyways, pretty neat, huh? EveryStepCalculus.com. Go to my site, buy my programs, and pass calculus. It's as simple as that. Have a good one.